The use of high-performance power connectors are on the rise. We've seen this in industries that are shifting toward electrification, especially in automotive and industrial sectors. And these systems require connectors that can handle higher currents with minimal losses. Now, high-performance connectors such as the REDCUBE series are particularly interesting in these growing roles in automotive applications. As vehicles become more electrified and power-hungry, then the demand for these robust, reliable, and low-resistance connections is more critical than ever. In today's episode, we're seeing how these terminals that are known for their exceptional current carrying capacity and their mechanical stability are meeting the rigorous demands of modern automotive design. From EV powertrains to advanced driver assistance systems, we'll unpack the technical advantages, design considerations, and the real-world use cases that are making these press-fit connectors a standout solution in the fast-evolving automotive landscape. You're listening to Würth Elektronik's What's Up radio podcast, and we're talking about what's up in the world of electronics and PCB design. We'll be checking in with leading industry experts, and our very own Würth Elektronik technical specialists are going to shine a light on topics such as energy harvesting, wireless power transfer, EMI issues, and today, high-performance connectors for automotive applications. Tune in to get technical design tips and applications during your commute, at your desk, or wherever you might be with Würth Elektronik's What's Up podcast. Now, many of us know that press-fit technology has been around for quite some time, and REDCUBE terminals actually stand out as the go-to choice for robust, high-power connections at the PCB level in automotive applications. They're widely employed for connecting wiring with cable lugs to circuit boards. The current rating of REDCUBE press-fit is seriously impressive. Even with the same power output, these components generate the least amount of heat compared to alternatives for powering PCBs. By pressing the pins directly into the PCB, there's a strong friction between the pin and the plated through hole, creating a seamless cold welding connection between the pin and the copper-plated via within the PCB. This delivers a secure, gas-tight, and mechanically strong connection with a contact resistance of less than 200 microohms. No other technology matches the ability to handle currents up to 250 amps with such minimal self-heating. In terms of long-term reliability, the REDCUBE press fits surpass a surface mount technology, or SMT, solder joint by up to 30 times. A single solid press pin typically requires a force of 100 newtons to extract it from a 1.6 millimeter PCB. So even a small component with 8 pins could handle the weight of an average person without being pulled out of the PCB. This makes REDCUBE press-fit terminals ideal for offering both electrical as well as mechanical connection solutions for electronic components. If after pressing the connector into the printed circuit board, the solid press pin interference on each of the 4 corners is greater than 3 degrees against the via sleeve, the press connection zone exhibits lower electrical resistance than the brass pin itself. This ensures there's no electrical or thermal bottleneck. Our first example shows a cross-section of the pressed pin in the via. Typically, the connection surface angle is significantly larger, offering ample safety margin for the electrical connection. The 3 degrees refers to the portion of a full circle's 360 degrees. Now, at the same time, this area should not exceed 12 degrees. Otherwise, the via copper plating can be damaged. The values specified in the datasheet will help to ensure compliance with this requirement. Press-fit technology offers several advantages over solder technology. It's particularly adept at handling very thick circuit boards with heavy copper plating. Additionally, it allows for trouble-free two-sided mounting of circuit boards, facilitating compact module designs. With press-fit technology, there's consistent contact between the pin and the copper layer along the entire length of the press-fit zone. This reliability is not assured with soldering, as solder may not fully rise along the entire length of the via, leading to increased transition resistances. Consequently, the long-term reliability and mechanical stability are not as robust as with REDCUBE's press fits. Now, unlike soldering, this process does not subject the circuit boards to thermal loading. These press-fit connectors from Würth Elektronik are crafted from a brass alloy comprised of copper, zinc, and lead, ensuring they comply with RoHS standards regarding copper alloys. As we already mentioned, REDCUBE press-fit terminals are capable of carrying currents exceeding 250 amps on the circuit board. However, it's crucial to evaluate the current carrying capacity of REDCUBE press-fit within the context of the entire system. Factors such as conductor path thickness, width, cable cross-section, ambient temperature, and heat distribution must all be carefully considered when selecting the appropriate REDCUBE press-fit terminals for the application. The press-fit zone itself exhibits extremely low resistance, ranging from 100 to 200 microohms. As a result, the limiting factor often arises from the layout of the connected conductor paths or the connection of external feed lines to a press-fitted component. Now, indeed, the challenge in designing high current application lies in achieving the optimal interaction among all components of the system. So what exactly is the process? Well, hot air leveling, or HAL, also known as HAL, as well as electroless nickel immersion gold ENIG PCBs are not recommended to use. HAL surfaces are inhomogeneous and reliable contacting across all layers cannot always be guaranteed. ENIG surfaces are very hard and brittle. This can lead to chip formation on the pin or to contact problems with the PCB in conjunction with the existing nickel layer. Now, on the other hand, immersion-coated PCB surface finishes ensure even distribution of tin throughout the via hole, and this makes it easier to meet tolerances and effectively prevents chip formation. Chips, plating, or solder push out of the via can actually affect the technical cleanliness of the system, and although rather unlikely, it could actually lead to short circuits as a conductive particle. REDCUBE press-fit terminals feature square-shaped press-fit pins. The design specifications for the through hole are actually outlined in the respective specifications and must be adhered to. For the best performance with a standard REDCUBE press-fit, the circuit board thickness should ideally fall within the range of 1.6 to 2.7 millimeters. The typical extraction force is approximately 100 newtons per pin for a PCB thickness of 1.6 millimeters. Greater circuit board thickness corresponds to correspondingly higher values. Mounting a copper rail to increase the current carrying capacity is also achievable with these press-fit terminals. Now, this can be done in two different ways. First, by press-fitting the copper rail beneath the circuit board, or by screwing it onto the REDCUBE press-fit. Now, during the press-fit process, it's important to ensure that the maximum overall thickness of the circuit board with the copper rail does not exceed 2.7 millimeters. Furthermore, REDCUBE press-fit terminals are ideally suited for fulfilling purely mechanical functions, such as connecting circuit boards to cases or even linking two circuit boards together. Here are some other design tips and tricks that you should really take into consideration when using REDCUBE press-fits. First, other components should be mounted at least 4 millimeters from the press-fit hole due to the slight PCB flexing during insertion, and the press-fit hole should also have a minimum distance of 3 millimeters from the edge. The press-fit force per pin should range from a minimum of 40 newtons to a maximum of 250 newtons. Typically, for a 1.6 millimeter PCB, then this force falls around 100 to 150 newtons per pin, and the exact values can actually be found in the respective datasheet. Next, during the entire press fit process, it's essential to support the press fit zone. Without proper support, there's a risk of the circuit board deflection during pressing. And this is especially crucial for pneumatic presses, where it's important to ensure that the stroke cycle is performed evenly and consistently. 3D printed or aluminum supporters are only suitable for a few samples. The stroke cycle should be executed in one movement, perpendicular and without angular misalignment to the PCB. This prevents defects in the via or even delamination of the printed circuit board. Following press fitting, the pins should slightly protrude from the circuit board and no components should be pressed against them. The recommended minimum separation is 0.1 millimeters. Also, keep in mind that these REDCUBE press fit terminals are specifically designed just for press fitting. Alternative processing methods like soldering are not recommended. Due to their high heat absorption, press fitting of the REDCUBE press fit should be carried out last, and this is after all soldering processes are completed. Resoldering REDCUBE press fit terminals after the press fit process is also not recommended. Resoldering can potentially lead to partial destruction of the cold weld and delamination of the circuit board. This could result in the permanent loss of mechanical stability in the press fit zone. And finally, to prevent mechanical damage to the press fit and the PCB, it's crucial to adhere to the maximum permissible torques. The exact values are found in the datasheet, but the force fitting speed should be a maximum of 250 millimeters per minute. If you'd like to learn more, head on over to our website where you can download the full data sheets and additional technical materials. You can also find all the images that were discussed in today's podcast attached onto this episode. Visit www.we-online.com/podcast to download the episode in its entirety. And if you're ready to get hands-on, you can actually easily order REDCUBE samples by reaching out to your regional Würth Elektronik contact. You can also chat with the live team at Würth Elektronik online, or now order directly through your MyWE customer portal. You're listening to Würth Elektronik's What's Up Radio podcast, where each month we're seeing what's up in the world of electronics and PCB design. We'll be checking in with leading industry experts and our very own Würth Elektronik technical specialists. We're going to shine a light on interesting topics such as energy harvesting, wireless power transfer, EMI issues, and so much more. Tune in to get technical design tips and applications during your commute, at your desk, or wherever you might be with Würth Elektronik's What's Up podcast.